G'day, we're going to look at some factorising by completing the square. This first example, you probably wouldn't use completing the square to factorise this, but I'm just going to use this one to show you the process of what happens with something like this. When we're completing the square, one of the things we're going to be doing is turning these into a perfect square. Key thing that we need to do is look at the coefficient of x, which is this bit here, and we want to divide that by 2. So I'm going to rewrite this: x squared plus 4x. Take the 4, and we need to divide that by 2. So 4 divided by 2. And what I'm going to do is do a little process. I'm going to go plus 4 divided by 2, take away 4 divided by 2, and with those two terms I'm going to square them like that. So this is now going to be equal to x squared plus 4x plus 4 divided by 2 is 2. I'm just going to leave those squares written there like that. What now happens is these first three terms here will become a perfect square. So what I'm going to do, the way this works, the easy way, is that x is going to come into a bracket. Whatever this sign is goes into the bracket. And then I take just the 2, not the squared 2, just the 2. Write that into the bracket. That now becomes a perfect square. Then I go take away 2 squared, so at this point in time I can change that to 4. I might leave it as 2 squared. This stage here that we've gotten to here, this is called completing the square. And to finish this off, to factorise it, we use the process of a difference of 2 squares. If you remember, the difference of 2 squares is a squared minus b squared equals a minus b, a plus b. So with our difference of 2 squares, the two things that are the squares, we've got our a, which is the first bit, and b, which is the second bit, becomes the 2 brackets. So it's going to be first bit, take the second bit in the first bracket, and first bit plus the second bit in the second bracket. In this case here, our first bit is x plus 2, so the bracket's going to become, I'm going to change, I'll leave it as green, x plus 2. And then the second bit of that is this 2 over here. So I'm going to go plus 2, and then x plus 2, which is the first bit, and then take away 2. A bit confusing with all the 2's everywhere. So to remember, this x plus 2 is from here, and that again is from here, and this 2 is from here, and that one goes to there as well. So the 2 brackets, one's going to be a plus, and one's going to be a takeaway when we create the 2 squares for our difference of 2 squares. Now to simplify that one, finish it off in green, equals, so x plus 2 will be x plus 4. The second bracket, x plus 2 take away 2, becomes just x on its own. You can write it like that, or you can bring that x out that's outside of the bracket and bring it out the front. Okay, so that's the answer to the question. To just go through the perfect square bit, I'll just zoom in on that for a minute to give me a bit of room. A perfect square, if we have x plus a squared, that's equal to x plus a, x plus a. And if I expand this out using FOIL, we end up with x squared plus ax plus another ax plus a squared, which becomes x squared plus 2ax plus a squared. Now, you should try to get into a habit of remembering the expansion of a perfect square from there straight to that last line without using FOIL. But to just go through a few things with this perfect square, what we're doing in the process that we did with completing the square in the example is we were taking these three terms here and bringing them back into the factorised form in the bracket. So this 2 that we have in front of the ax is why we divide by 2 up the top there. If you do the comparison, so we're going to have an x and an x squared is the first term, the a is the a squared in the last term, 2 times a times x is the middle term there. So to get the middle term here, we divide that by 2, just the number by 2, which brings us to the a. Right, we'll go through some more examples I've got here. So we're going to be completing the square. Excuse me. So firstly, I'll write out x squared plus 6x. I'm going to put into here the plus 6 divided by 2. Remember, we take the coefficient of x and divide that by 2. We square it, then we go take away 6 divided by 2 squared, and then we bring down the take away 1, which is at the end. So the black bits are all in the original. I've added the 6 plus 2 and taken away the 6 plus 2. Now, the reason that you always go add first here and then take away is if we've got perfect squares in the bracket, negative times a negative will always be a positive, so we always need to be dealing with a positive term there with a perfect square. So I'll come back to my equation here, and I'll just rewrite this x squared plus 6x plus 3 squared, take away 3 squared, take away 1. Now, our first 3 terms will become the perfect square. So this will be equal to, we'll open the bracket. Now remember, we get our x goes into the bracket. Then whatever that sign is goes into the bracket. Then that number there without the square goes into the bracket. Then we'll turn that we'll make that squared. So that's our perfect square. And then we go take away 3 squared, which is 9, and take away 1, which is equal to x plus 3 squared minus 10. Now that there is the stage of completing the square. Now to factorise it, what we're going to do is to do a little trick. We say we're going to square root that, and then we'll square it as well, which then allows us to do our difference of 2 squares. So for our 2 brackets that we're going to have the first bit, x plus 3, take away the square root of 10, which is from the second bit there, and then we're going to do our second bracket, which is going to be plus x plus 3 plus the square root of 10. Now, if that 10 was a 16 or something that we can take a square root of, then you would obviously use that number, but if you can't do that, just leave it in surd form, and that will be your answer. Next example. Okay, once again, equals x squared minus 8x. Then I go plus 4 over 2 squared, take away 4 over 2. Let me rewind that, go back again. Must be late. Because the 4 doesn't exist, I'm thinking of the answer before I actually did it. Sorry about that. So we now go plus 8 over 2 squared, take away 8 over 2 squared. Why is it 8 over 2? Because the original question has got 8 in it, not 4. 8 divided by 2 is 4. That's what I was doing. And then we're going to go plus 3, which is our 3 from the original question. Now, to bring this down, we need to take that, and 8 divided by 2 simplified as 4 goes into a bracket. So we're going to have x take away 8 divided by 2 is 4 squared. And then we go take away 8 divided by 2 is 4 squared plus 3. So that bit there has become that bit there has become that. These 3 terms here have gone into the bracket. So I'll just simplify those last terms. X take 4 squared minus 16 plus 3 equals x take 4 squared take away 13. Now if you remember that little trick that we do, we're going to take the square root of that and we're going to square it. Squaring the square root of something just gives you the normal number. So if I had 25, for example, if I took the square root of 5, that's equal to 5. But if I then square them, it just goes back to the original answer. So we don't need to worry about that. Just as a little side note, I'll get rid of that there so it doesn't confuse you too much. So the next thing that we need to do is to do our difference of 2 squares. A squared minus b squared equals a minus b, a plus b. So we write our first bracket, x take away 4, take away square root of 13, x take away 4 plus the square root of 13. Okay, let's go on to the next example. Now this one here, we've got a coefficient of x squared. So the first thing I'm going to do is to look to see if the 2 in front of the x squared goes into all the other numbers. It does, so I'm going to factorise it by bringing that 2 out. And that'll leave me with x squared plus 12 divided by 2 is 6, 6x, take away 4 divided by 2 is 2. So now what we need to do is, for that bracket that's there, we're just going to deal with what's inside that bracket. In a moment I'll rewrite that with a square bracket. The square bracket is no different to a round bracket, except the shape of it. And the reason I put that in is it's easy to see the pair of square brackets instead of having multiple curved brackets. So what we'll do is we'll go equals 2. I'm going to open up a square bracket. X squared plus 6x. Then if you remember, we go plus 6 divided by 2 squared, and then we go take away 6 divided by 2 squared. It's always divided by 2 when you're adding those 2 terms in. And then we're going to go take away 2 as our last term. Now just remembering that 2 there goes down to there, and then those terms just go straight down. This 6 divided by 2 is what goes into these bits here. So equals 2 square bracket. Now I'm just going to do a round bracket here. X plus 6 divided by 2 is 3 squared, minus 6 divided by 2 is 3, so we'll call that 3 squared, take away 2. And again remembering that 6 divided by 2 goes to there, that plus sign goes to there, this x goes to there. this bit here becomes that bit there. Simplify this, equals 2, keeping the square bracket in play for now, and we go x plus 3 squared, take away 3 squared. 3 squared is 9, so take away 9, take away 2 is take away 11. Then what we do is we'll apply the difference of 2 squares to that. Remember, we're just dealing with what's inside that square bracket. So we go x plus 3, take the square root of 11. If you remember the difference of 2 squares, x plus 3 plus the square root of 11. And then we don't need to write the square brackets in the end. We don't need to multiply by the 2. So I'll just rewrite that again. 2 x plus 3, take the square root of 11. X plus 3 plus the square root of 11. And that's so on. We'll go on to another example. This one. So equals x squared plus 3x. This isn't an even number. We're going to deal with some fractions. So it's going to be plus 3 over 2 squared. Take away 3 over 2 squared. Take away 1. Now fractions aren't scary. So these first 3 terms here will become our perfect square. So this is going to equal x plus 3 over 2, just leave it as an improper fraction, squared, take away. Now if you can't remember how to square a fraction, we're going to be squaring the 3 on the top and squaring the 2 on the bottom. So squaring the 3 on the top becomes 9 over squaring the 4 on the bottom becomes a 4, squaring the 2 on the bottom becomes a 4. So take away 1. Because we've got a denominator of 4 for the 9 on 4, I'm going to make the 1 also a fraction over 4. So 1 is equal to 4 over 4. So this is now equal to x plus 3 over 2 squared, take away. Now that we have a common denominator with the fractions, we just deal with the numerator. So we're going to have negative 9 take away 4 is negative 13 over 4. Now to complete the square, we have to take a square root of that second term because it's not a perfect square. So I'm just going to write over on the right here what we do with that. So 13, square root of 13 over the square root of 4 is equal to the square root of 13 over the square root of 4. We can take a square root of 4, which is 2, so this will end up as root 13 over 2 for that one. And that's what's going to go into our brackets. So we've got x plus 3 over 2, take away the square root of 13 over 2. And we have x plus 3 over 2 plus the square root of 13 over 2. And that is the factorised form of that. We're going to the next example. And this will be the last one. So now what we do, start off as we do, equals x squared plus 2x plus 2 divided by 2 squared, take away 2 divided by 2 squared, plus 10, which is equal to, remember the first term comes down, the x, and then we have that sign, plus, and then we have our 2 over 2, which simplifies to become a 1 squared. then we've got to go take away 1 plus 10. 2 divided by 2 is 1, and then when we square it, it's still 1. 1 times 1 is 1. Just remember that that sign has to stay as a takeaway. When we do BODMAS for the 2 over 2 squared, it's not negative 2 squared. We're taking away a squared number. So we keep the takeaway there. And this is going to equal x plus 1 squared plus 9. Now, a problem that we have here, if you remember our difference of two squares, a squared minus b squared equals a minus b and a plus b. The issue that we have here is that this is a plus, and for the difference of two squares we need to have a takeaway between them. So in this case here we can't actually go any further to factorise this term. When we get to the stage of graphing quadratic equations, you'll find that this is a graph that's actually above the x-axis, doesn't actually cross the x-axis. So there's not going to be any solutions to this one. So we'll just leave it at this one here. Because of that plus, we can't go any further with this particular question, and we just leave that as our answer to writing it into completing the square, which is also called turning point form. But that'll come when we've got the graphs. So I hope you've got a little bit from that. You might need to just watch over a few of those again, follow the steps, and that should get you out of trouble. Okay.